AWS Lake Formation. AWS Lake Formation. 1. Managed Data Lake Service. AWS Lake Formation is a fully managed service designed to make it easy for users to set up, secure, and operate a data lake. 2. Secure Data Storage. It centralizes the storage of structured and unstructured data, often leveraging Amazon S3, while ensuring high levels of data security. 3. Data Cataloging and Discovery. AWS Lake Formation aids in cataloging and organizing data, making it easily discoverable for analysts and data scientists. 4. Fine-grained access control. One of its standout features is the ability to set fine-grained access controls, allowing detailed specifications on who can access what data and how. 5. Seamless AWS integration. AWS Lake Formation integrates smoothly with other AWS analytics and machine learning services, enabling users to harness the full power of the AWS ecosystem. 6. Simplified data lake setup. It streamlines the process of creating a data lake, removing much of the manual and time-consuming tasks, leading to quicker deployments. Benefits of using AWS Lake Formation. 1. Simplified data lake setup. AWS Lake Formation streamlines the process of creating a data lake, reducing setup time. 2. Enhanced data security. With its fine-grained access controls and encryption capabilities, it offers robust data security. 3. Cost-effective scalability. Being on AWS, it provides scalability benefits of the cloud, allowing storage and processing expansion without large upfront costs. 4. Data discovery and cataloging. It eases the discovery of data by cataloging datasets, making it simpler for analysts to locate and use the right datasets. 5. Integration with analytics tools. AWS Lake Formation integrates seamlessly with AWS analytics and machine learning services, offering a powerful analytics ecosystem. 6. Centralized data management. It centralizes the storage, discovery, and security aspects of data, leading to better data management practices. When to use AWS Lake Formation. 1. Large-scale data analysis. Utilize AWS Lake Formation when dealing with massive datasets that require complex querying and analytics. 2. Multi-source data integration. When you need to integrate data from diverse sources like RDBMS, logs, or streams into a unified data lake. 3. Secure data storage needs. Opt for AWS Lake Formation when you want to ensure data security through encryption, access controls, and audit capabilities. 4. Dynamic scalability requirements. When you expect variable data loads and need the flexibility to scale storage and processing capabilities dynamically. 5. Advanced analytics and ML tasks. If you're planning to perform advanced analytics, machine learning, or AI tasks on your data, AWS Lake Formation provides seamless integration with AWS tools for these purposes. 6. Data governance implementation. Use AWS Lake Formation when aiming to implement robust data governance practices with data cataloging, versioning, and access controls. Key terminologies of AWS Lake Formation. 1. Data lake, a centralized storage repository that allows storing structured and unstructured data at any scale. 2. Data catalog, a central repository in AWS Lake Formation that stores metadata and makes data discoverable and queryable. 3. Permissions model, defines who can access specific datasets and how they can interact with them within the data lake. 4. Blueprints, ready-to-use templates in AWS Lake Formation that help in automating the process of setting up data lakes. 5. Crawlers, programs in AWS Lake Formation that automatically scan data in data lakes and extract metadata, adding it to the data catalog. 6. Workflows, a sequence of steps that perform data preparation, loading, and analytics tasks in AWS Lake Formation. Features of AWS Lake Formation. 1. Data lake building, simplifies the process of setting up, securing, and managing a data lake infrastructure. 2. Security and access control, provides granular data access controls, encryption in transit/at rest, and audits for security. 3. Data cataloging, enables centralized storage of metadata, making datasets easily discoverable and queryable. 4. Automatic data crawling, uses crawlers to automatically classify and register schema from new datasets into the catalog. 5. Blueprint provisioning, offers predefined templates to automate data lake setup, integrating data sources and targets. 6. Workflows and data preparation, automates tasks for data cleaning, ETL processes, and preparation for analytics. 7. Cross-account sharing, allows securely sharing datasets across multiple AWS accounts without data copy or duplication. Limits and quotas of AWS Lake Formation. 1. Resources per region. AWS Lake Formation supports up to 20,000 resources, tables and databases, for each AWS region. 2. Named resource links. There is a limit of 1,000 named resource links per data lake. 3. Maximum blueprints. Users can create up to 100 blueprints for automating data lake creation. 4. Concurrent crawling jobs. At any given time, you can run up to 50 crawling jobs concurrently to extract metadata. 5. Granular permissions per principal. A principal, like an AWS identity and access management role or user, can have granular permissions on up to 20 resources. 6. Tags per resource. You can assign up to 50 tags to each resource, table, database, etc. 7. Maximum workflows. A limit of 300 workflows can be defined for automating data tasks within AWS Lake Formation. Settings for creating AWS Lake Formation. 1. Data lake location. Choose an Amazon S3 bucket location for your data lake where the data will reside. 2. Administrator settings. Designate an AWS IAM role or user as the data lake administrator with full permissions. 3. Security and access roles. Assign IAM roles that AWS Lake Formation can assume to access data sources and perform operations. 4. Data source integration. Specify data sources like databases, logs, or streams that will be ingested into the data lake. 5. Blueprint configuration. Opt to use any of the predefined blueprints for quick data lake setup and data ingestion. 6. Crawling schedule. Define how often crawlers run to discover and catalog new datasets in the data lake. 7. Data encryption options. Decide on encryption settings, either server-side encryption with Amazon S3 Managed Keys, SSE/S3, or AWS Key Management Service, AWS KMS, keys. AWS Lake Formation integrations. 1. Amazon S3. AWS Lake Formation primarily integrates with Amazon S3 for data storage, creating a centralized repository in S3 buckets. 2. Amazon Redshift. It integrates with Redshift for advanced data warehousing, allowing users to execute complex queries and analytics. 3. AWS Glue. AWS Glue is used for ETL tasks, data cataloging, and metadata storage within the Lake Formation environment. 4. Amazon Athena enables serverless querying of data in the data lake using standard SQL without the need for infrastructure setup. 5. Amazon EMR. AWS Lake Formation integrates with EMR for processing vast amounts of data using popular frameworks like Spark, Hadoop, and Hive. 6. Amazon QuickSight. For visualization and business intelligence, Lake Formation integrates with QuickSight, allowing users to create interactive dashboards. 7. AWS Identity and Access Management, IAM. IAM roles and policies facilitate granular access control and permission management for data lake resources. Underlying technology of AWS Lake Formation. 1. Centralized data storage. AWS Lake Formation leverages Amazon S3 for creating a centralized data lake. It manages and organizes vast amounts of structured and unstructured data in S3 buckets. 2. Metadata cataloging. Lake Formation uses AWS Glue's data catalog as its native catalog to store metadata and make datasets discoverable. 3. Access control mechanisms. Built on top of AWS IAM, Lake Formation provides fine-grained, table, and column-level access controls, ensuring specific data access to authenticated and authorized entities. 4. Data crawling and cataloging. It employs crawlers that scan and catalog data automatically. These crawlers infer schemas and add the metadata to the data catalog. 5. Blueprint automation. Blueprints in Lake Formation are templates that simplify the process of setting up a data lake by automating data ingestion from diverse sources. 6. Encryption and security protocols. Lake Formation supports encryption at rest with Amazon S3 server-side encryption and encryption in transit using TLS. It also allows for continuous monitoring and auditing via AWS CloudTrail. 7. Workflow automation. Lake Formation automates various data tasks like cleaning, ETL processes, and data transformation using workflows, enabling seamless data preparation for analytics. Cost and pricing of AWS Lake Formation. 1. No direct charge. AWS Lake Formation itself does not have a direct charge for its features. You pay for the underlying AWS services it uses. 2. AWS Glue data catalog costs. You're billed for storing and accessing metadata in the AWS Glue data catalog, which Lake Formation uses natively. 3. Amazon S3 storage costs. Charges are incurred based on the amount of data stored in Amazon S3 buckets and the number of S3 API calls made. 4. AWS Glue ETL and crawling costs. There are charges for ETL jobs and crawlers that run. This depends on the data processing unit, DPU, hours and crawler runtime. 5. Data transfer charges. Transferring data out of AWS Lake Formation to the internet or other AWS regions might result in additional costs. 6. Integration service costs. If integrating with other AWS services like Amazon Athena, Amazon Redshift, or Amazon EMR, respective service costs apply. High availability and reliability of AWS Lake Formation. 1. Built on AWS infrastructure, AWS Lake Formation leverages the robust infrastructure of AWS, inheriting its high availability and fault tolerance features. 2. Data replication across AWS. Lake Formation utilizes Amazon S3 for storage, which replicates data across multiple availability zones, AWS, ensuring high availability. 3. Automatic failover mechanisms. In case of component failures, AWS Lake Formation has mechanisms in place to automatically reroute traffic to healthy components, ensuring uninterrupted service. 4. Consistent data integrity. Reliability is also about data correctness. Lake Formation maintains data integrity by ensuring consistent data storage, cataloging, and access. 5. Monitoring and automatic recovery. AWS Lake Formation is closely integrated with AWS CloudWatch and other monitoring services, allowing for real-time monitoring and automatic recovery in case of failures. Fault tolerance and failover in AWS Lake Formation. 1. Redundancy in storage. By utilizing Amazon S3, data is redundantly stored across multiple AWS, ensuring fault tolerance in the event of component failures. 2. Continuous health checks. AWS Lake Formation continuously monitors service components, enabling early detection of failures. 3. Recovery from data errors. In case of data errors or corruption, AWS Lake Formation provides mechanisms to restore correct data versions, ensuring reliability. 4. Distributed architecture. Its architecture is designed to operate across distributed components, ensuring that if one component fails, others continue to function, leading to inherent fault tolerance. 5. Seamless data restoration. For scenarios where failover mechanisms are triggered, AWS Lake Formation ensures that data is seamlessly restored, providing uninterrupted service. Security aspects of AWS Lake Formation. 1. Granular access controls. AWS Lake Formation offers fine-grained access controls, allowing you to specify who can access specific datasets and how they can interact with them at table and column levels. 2. Encryption in transit and at rest. Data is encrypted in transit using TLS and at rest using Amazon S3 server-side encryption with either Amazon S3 Managed Keys, SSE/S3, or AWS Key Management Service, AWS KMS, keys. 3. Audit with AWS CloudTrail. AWS CloudTrail integration allows for the monitoring and auditing of all API calls, giving visibility into user activity and data access. 4. Data Lake Firewall. This provides additional security by controlling network traffic to and from AWS Lake Formation, ensuring only legitimate traffic reaches the service. 5. Cross-account access. AWS Lake Formation allows secure sharing of datasets across AWS accounts without data duplication, ensuring controlled and audited access. 6. Integration with AWS IAM. AWS Lake Formation utilizes AWS IAM for user authentication and role-based access control, ensuring only authenticated and authorized entities can access data. 7. Compliance standards. AWS Lake Formation adheres to various compliance certifications, ensuring data security and privacy. Logging and monitoring in AWS Lake Formation. 1. AWS CloudTrail integration. AWS Lake Formation integrates with CloudTrail to capture all API calls, allowing for detailed logging and auditing of actions taken within the service. 2. AWS CloudWatch Metrics provides metrics related to AWS Lake Formation, helping monitor operations, data access, and system performance. 3. AWS CloudWatch Alarms set up alarms based on specific CloudWatch metrics thresholds to receive notifications on potential issues. 4. CloudWatch Logs capture logs related to AWS Lake Formation operations, aiding in troubleshooting and providing insights into data access patterns. 5. Audit Logs. These logs provide a detailed history of data access and modifications, ensuring transparency and aiding in compliance. 6. Data activity monitoring. AWS Lake Formation continuously monitors data activity, allowing for real-time insights into data access and modifications. 7. Service Health Dashboard offers insights into AWS Lake Formation's operational status, helping identify and respond to service interruptions. Best practices for AWS Lake Formation. 1. Centralized data storage. Store all data in a centralized manner within the data lake, ensuring data consistency, easier management, and unified access. 2. Implement granular access controls. Make use of Lake Formation's fine-grained access controls to define specific data access at table and column levels, ensuring data privacy and security. 3. Regularly audit and monitor. Regularly monitor AWS Lake Formation operations using CloudTrail and CloudWatch. Audit logs frequently to ensure compliance and identify any unauthorized activities. 4. Use blueprints for automation. Utilize blueprints to streamline and automate data lake setup and ingestion processes, ensuring consistency and reducing manual errors. 5. Maintain data catalog hygiene. Regularly update the data catalog, removing outdated entries and ensuring metadata is accurate and up to date. 6. Optimize for cost efficiency. Monitor costs using AWS Cost Explorer, and consider data lifecycle policies in Amazon S3 to move infrequently accessed data to cheaper storage classes. 7. Encrypt sensitive data. Always encrypt sensitive data, both in transit and at rest, using Lake Formation's encryption options to ensure data security. AWS Lake Formation versus traditional data lakes. 1. Managed service offering. AWS Lake Formation is a fully managed service, which eliminates the need to set up, patch, or manage any servers, simplifying infrastructure management. 2. Granular access controls. Lake Formation provides table and column level access controls, ensuring fine-grained data access, which is often more challenging in traditional setups. 3. Blueprint for automation. Ready-to-use templates in Lake Formation allow for the rapid and consistent setup of data lakes, automating many traditionally manual processes. 4. Integrated data cataloging. AWS Lake Formation has built-in data cataloging using AWS Glue, which makes data discoverable, organized, and queryable. 5. Seamless AWS integrations. Being an AWS service, Lake Formation has out-of-the-box integrations with other AWS analytics, machine learning, and storage services. 6. Cross-account data sharing. Lake Formation has unique capabilities for securely sharing data across multiple AWS accounts without duplicating data. 7. Built-in security and compliance. Integrated with AWS security tools, Lake Formation offers encryption, audit trails, and compliance certifications. 8. Scalability and performance. Built on AWS infrastructure, Lake Formation offers the cloud scalability and performance benefits, handling vast amounts of data with ease. 9. Centralized Management Console. AWS Lake Formation provides a centralized console for managing the data lake, offering a unified view and control. 10. Cost efficiency with cloud optimization. With AWS's pay-as-you-go model and integration with cost optimization tools, Lake Formation can be more cost-effective than traditional on-premises solutions. Integrating AWS Lake Formation with third-party tools. 1. JDBC and ODBC drivers. Many buy and analytics tools can connect to AWS Lake Formation using JDBC or ODBC drivers, allowing direct querying of data. 2. AWS Glue Data Catalog Connectors. Use connectors to enable third-party tools to access metadata stored in AWS Glue, which is natively used by Lake Formation. 3. API integrations. Certain tools can directly integrate with AWS services using APIs, fetching and visualizing data stored in Lake Formation. 4. Export and import data mechanisms. Some tools may require data in specific formats. Lake Formation can export data in these formats, or these tools can import from Amazon S3 directly. 5. IAM role-based access. Ensure that third-party tools have the necessary AWS IAM roles and permissions to access Lake Formation data securely. 6. SQL query compatibility. Tools that support SQL can query Lake Formation data, especially if they're integrated with Amazon Athena. 7. S3 Select and Athena Federated Query. These services allow querying data directly in S3, used by Lake Formation, and integrating with external data sources. 8. Data streaming interfaces. If real-time analytics is needed, integrate Lake Formation with streaming services and then connect to tools that support real-time data visualization. 9. Pre-built integrations. Some popular third-party tools come with pre-built integrations for AWS services, simplifying the connection to Lake Formation. 10. Custom scripting and SDKs. For tools without direct integration, custom scripts or SDKs can be used to fetch data from Lake Formation and feed it into the tool. Querying data in AWS Lake Formation. 1. Amazon Athena, a serverless query service that allows you to analyze data in AWS Lake Formation using standard SQL without any servers. 2. Amazon Redshift Spectrum, extends the capabilities of Amazon Redshift to query data directly from Lake Formation, combining data warehousing with data lake queries. 3. AWS Glue ETL jobs, use Glue to write ETL jobs in Python and Scala that can query, filter, and transform data stored in AWS Lake Formation. 4. Amazon EMR with Hive and Spark, deploy big data frameworks like Apache Hive and Apache Spark on EMR clusters to query and process data in AWS Lake Formation. 5. SQL with JDBC and ODBC drivers, connect various BI and analytics tools directly to AWS Lake Formation using JDBC or ODBC drivers for SQL-based querying. 6. AWS SDKs and APIs, use SDKs in various languages to write custom code that queries data via AWS Service APIs. 7. Third-party BI tools, tools like Tableau, Looker, and Power BI can be integrated using connectors or drivers to query Lake Formation data. 8. AWS Data Wrangler, a Python library that extends the power of Pandas library to AWS, connecting data frames and AWS data-related services. 9. AWS QuickSight, AWS's own business intelligence tool, can be directly connected to Lake Formation for visualization and analysis. 10. AWS Boto 3 for Python, utilize Boto 3, the AWS SDK for Python, to write custom scripts that can query and manipulate data stored in AWS Lake Formation. Thanks for